Hello, friends. Welcome to the Nexus Podcast. I'm your host, James Dice. Each week, I fire questions at the leaders of the smart buildings industry to try to figure out where we're headed and how we can get there faster without all the marketing fluff. I'm pushing my learning to the limit, and I'm so glad to have you here following along. This episode is a conversation with Beth Eckenrode and Craig Stevenson, founders of Auros Group, a consultancy dedicated to constructing, designing, and building the highest performing buildings at the lowest possible cost. We talked about how building science, or the practice of creating high performing building envelopes, combined synergistically with data science, a topic that we're more used to talking about here on the podcast. Then we turned our attention to how that actually happens in practice and what it costs in the real world. These insights are key to our decarbonization journey, and I hope you enjoy them. So without further ado, please enjoy the next podcast with the Auros Group. Hello, Craig and Beth. Welcome to the show. Can we start with you, Beth? Can you introduce yourself?
Sure. Thanks for having us, James. Really excited to be here. We're rather new to Nexus Labs, and we've really enjoyed learning so much from you and the whole ecosystem. So the background on me is I've experienced with big companies running billion-dollar businesses, and in about 2014, I got bit by the bug to take my skills and go do something that matters. And I connected with Craig on the future of the built environment. And what was interesting was how much change was necessary in an industry that is fundamentally resistant to change. And as a strategist and as a practitioner, I found that to be really interesting. I thought between the two of us, we had an approach and some thoughts around how to get any building owner, whether it's an owner of an existing building, lots of buildings, a developer, a university of existing buildings, or somebody attempting to build a new building in today's times where goals are aspirational, zero carbon, zero energy, healthy indoor air quality. We felt like we had the pieces of the puzzle to put that together in a way that, owners could get excited and feel like they could deliver on those goals. As we processed it through, what we realized is that we had to be ready to explain and justify and support to building owners that they got what they paid for. So the combination of, the aspirations and the need to prove performance to us was an interesting bringing together of spaces that weren't together. There are a lot of gaps that exist in the construction cycle, for sure. And we felt like if you closed a couple of the right ones and you did it in a way that didn't cause as much disruption. So how do you go after something that's a disruptive innovation in the least disruptive way possible? That's what we set out to do. That was kind of our mission. And so much so we wrote a book. It was published last year called The Power of Existing Buildings, which does exactly that. It kind of takes an owner or developer, somebody who has a lot of buildings, and says, okay, how do you think about taking the steps all the way from either renovation or an existing or a new building? How do you go all the way from design through to operations and start to close some of those gaps?
Cool. And those of you that are watching on YouTube can see this book across Beth's left shoulder here. But for those of you that are listening on audio, we'll put the link to the book in the show notes. So Craig, can you introduce yourself for us?
Absolutely. Hi, James. Craig Stevenson, co-founder of the Auros Group. Beth and I are business partners here. We really appreciate the opportunity to speak with you at this podcast. I've learned a lot going back through your podcast libraries and watching them. So thank you for doing what you do. My background is I grew up in the construction industry. After I graduated college, I went into the construction as a general contractor. I was working for mid-sized general contractors. And I did that pretty much for 25, 30 years. I grew up estimating. I grew up understanding fundamentally how buildings get built. And one of the things that I learned very quickly is we can do better without spending a premium. I was early adopter in the sustainability, and I've watched greenwashing in my career, and I've watched people checking boxes and calling it sustainable. And it frustrated me because, like I said, climate change is upon us, and I know we can do better, and I know we can do better without spending a premium to get there. So when I dove in, everything I've researched and everything I looked into pushed me to envelope first approaches, efficiency first solutions to buildings. It's the cheapest way to do it. Efficiency is the cheapest form of energy. And when you see a detail for an envelope first approach, you really can't unsee it. So it's just a logical way to build. And when we started talking to clients about this, they were interested. They're definitely interested in efficiency. They're interested because it's the right thing to do, and they're interested because regulations are forcing them to figure it out. But they were skeptical, and their skepticism was around, those prescriptive programs. Do this, and you should get that. And they did that forever, and the buildings never really changed fundamentally in how they operated. So what we figured out very quickly is we needed to have a feedback loop. Right, we needed to have some level of connectivity from design and construction to operation, so our owners would gain trust in how we're approaching this building efficiency solution. That's what started this whole concept. That's what drove us. That's where Beth and I spent a lot of long days and weekends thinking about it, hatching, and it eventually developed to what is now Auros Group, where we merge building science and data science to get at zero energy, zero carbon, and world-class indoor air quality.
Awesome. And we met, I think, at RealCom this past fall, and you had like this mic drop moment where you were talking about, like, you were speaking to a room of MSIs, and you were basically just, I don't remember what the exact quote was, but it was about building science and data science, and I was like, I have to get this guy on the podcast. So I'm so glad you guys are here. I think you also came to me through Joe Gaspardoni, so shout out to Joe for making the introduction. Well, let's dive in. So tell me a little bit about your clients and the types of projects that you guys work on. It sounds like construction projects all the way through to operations. What point in the construction process do you guys get involved in a project?
Well, I'll pick it up on clientele, and I'll let Beth come in and talk about how we engage and how we should start, when we should start thinking about this. But in terms of our markets, we focus at Auros Group on larger commercial projects in the MUSH market, municipal, university, schools, hospitals. A lot of multifamily these days, because multifamily is using the pacify strategy to get to zero. It's just natural for those types of buildings to do it. Envelope first approach for other buildings that have high process loads is natural as well, but you don't see that one-to-one relationship like you would in a multifamily, which is really kind of just, it's super easy to do. So those are the types of clients that we typically will engage with. And when we come on those project teams, we can come on project teams for new buildings. So there's a concept that we want to do something new. We can come into buildings for existing buildings that have a massive trigger, like major retrofit, or they have life cycle triggers for systems or windows. That would be a natural point to bring us on. And we can also come into projects that have existing buildings with no triggers. And what that entails is really creating a master plan so that when that trigger hits, we know what to do. Because the concept of replacing in kind, our mechanical systems go down, put the same size system in and replace it, and not try to influence those loads and look at our envelope at that same time, which is the right time to do it. You miss the opportunity to spend your money more wisely. So we do some master planning for existing buildings, and we also talk about existing and new. And in terms of when, Beth, I'll defer to you if you want to come in on that.
Sure. So Craig laid out all the places. The how and when we come in differs based on project goals. So depending on what an owner's interest is, it affects the way we might approach a new project, whether it's an existing building or a new building. For example, a university system that wants to figure out which is the next building that they could, in the most cost-effective way, drive that building to zero energy or zero carbon. How do they rack and stack their investment options? That's one way we might come in with an existing building. Somebody who has a specific building, like Craig says, with triggers and already knows what they're trying to accomplish. Now we go more into execution mode as opposed to planning mode. But what kind of weaves together and threads all of our clients is the set of goals that they go after. So our clients, whether they're a university or they're a K through 12 or multifamily, or all different sizes and types of municipalities, they will have a set of goals or objectives that they're targeting, some that are required of them and others that are just elective. And that's what really weaves together our clients. They're all going after zero carbon, zero energy. They want, especially post-COVID, they want to know that they're putting their people in the highest quality buildings that they can be in. And there's a certain equity to that, right? The equity is everybody should be able to live and learn and play and work in environments that contribute to their overall health and well-being. Those are the kinds of clients that, most define our base.
Cool. And in my perception, I've been writing a lot about this recently, but this trigger or this goal setting or whatever the impetus is for action, I find that a lot of building owners are sort of, it depends on the industry, right? Some are more advanced than others in different industries, but the actual concrete plan with concrete steps and a deadline isn't necessarily there for a lot of the organizations that are setting these big, big targets and doing press releases and that kind of thing. Is that what you guys would come in right there and say, here, let us help you put together an exact plan for you to get to that target and have it be less of a greenwashing situation?
For sure. We would come at that from the standpoint of, how do you make the most amount of progress towards your goals with the least amount of cost? So we look for the biggest bang for the buck. Like, you have a building that is facing, failure in something, a system of some sort. That's the opportunity now to rethink that entire building, not just that system. And so, as Craig was saying, we use tools like, modeling and simulation, whole building performance modeling and simulation. We do that in order to predict performance. By predicting performance, we're able now to take cost estimates along with the predicted performance and be able to, in a much more definitive way, line out options for clients on, hey, here's where you want to spend your next dollar. You don't want to spend it over here. You want to spend it over here. And this is why. This is the return on investment you'll get on that spend.
Cool. So let's circle back to this concept of building science and data science. So Beth, can you just kind of explain this concept at a high level? Why is this combination important?
Sure. So we naturally come at this, our history and our background and kind of everything based on where we started is from the building science perspective. And what we realized as we were processing through the building science is that the building science without connecting into the world of data science was not, we don't have perfect context if we don't do that. So we look at kind of the juncture of building science and data science as a tool in terms of physics-based, whole building physics-based modeling and simulation. And the reason why we think that's so important is that both worlds of scientists speak that language. So building scientists speak the language of whole building performance and modeling and simulation, and data scientists speak that same language. And so our objective in every project is to try and pull more of that together, do more collaboration. So simulation and modeling in the hands of building scientists results in the highest performing building at the lowest possible cost. It results in the achievement of the aspirational goals that owners want in terms of the zeros, the zero carbon, the zero energy, and indoor air quality, and the rest of that. But simulation in the hands of data scientists provides context of either what's possible or what should be. And that should be important to building owners and developers because, just comparing a building against itself, it's not the right paradigm for the type of progress we're looking to make to achieve these goals. And especially for clients who are ESG focused, there's a certain amount of ESG you get, like the low-hanging fruit. You pick a couple pieces of the low-hanging fruit and you've got something, but you get to a point where you're like, how do I get the rest of this? How do I get the rest of the meal? The rest of the meal comes by bringing together these worlds of building science and data science and using tools that everybody shares. Everybody has the access to the same data. Everybody then is informed by the same choices, by the same options. And then building owners and developers have more information to make higher quality decisions. So we view it as kind of the way to close the gap and bring together the type of collaboration that just hasn't been there in the past.
I want to add something to that. So I think that the way in which Beth described how we merge building science and data science is spot on. But I wanted to mention an analogy for the data science community that should resonate, right? What's the common thread that goes through everything we do? When we talk about setting goals and targets, and we do that through establishing an owner's project requirements, we're using metrics. We're not talking about, hanging a plaque or doing prescriptive criteria. We're saying this building wants to be at a 14 EUI. The air quality and air parameters in the building want to be at these set levels. Those are all based on metrics. The OPR is based on metrics. When we go into the design support using building energy modeling, the building energy modeling is giving us metrics, and we're making sure that those metrics align with our OPR. What are we doing in the data science community, right? We talk about time series data and we're looking at metrics, we're looking at numbers. That's the common thread across all this. That's why it's so logical that when we talk about merging building science and data science, it makes so much sense because everybody is now talking about the same levels of goals and targets, and they're all based on metrics.
And I'll add to Craig's comment about real world challenges. You had a podcast not too long ago with a couple folks from Stanford, and I think it was Jerry Hamilton, who was talking about a real world problem that they're trying to solve regarding temperature in their rooms, that there's the temperature that's on the thermostat, but then there's the actual temperature in the middle of the room, or the temperature on the end of the room, or the temperature in front of the window when the sun's out or when the sun's not out. And the kinds of things that we're talking about in terms of, building science and bringing together the data science and the building science, that's where you start to fix those problems. So in a building science environment, those problems go away when you put the systems together properly. And we'll cover that in the discussion on building science.
That makes sense. I love when we have cross podcast episode conversations going, people reacting and commenting on past episodes. I love that. So Craig, why don't you do a deeper dive because I want to circle back and make sure I understand what building science and data science, what you guys mean by that, but maybe we do a deep dive on each of them and then we'll kind of reflect at the end on what they mean together. I maybe have some follow-up questions there. So Craig, what do you mean by building science?
Yeah, I'll give you an example because sometimes it's easy to imagine a story, right, in terms of what we do. So let's assume I want to build a new building and I go to my code and I'm doing it in the northeast part of the United States. Code is going to dictate that my envelope, my wall envelope, my assembly from cladding all the way to drywall has got to be around like an R18 to an R20 to meet code-based standards. They're going to require me to put an air barrier in, but they're not going to require me to test it. And they really don't care what kind of windows I put in, right? So they're going to give me certain code criteria that I have to meet for how I build that building. And what we say is, well, wait a second, what is the inflection point where insulation stops paying? Because insulation is always cheaper than systems, right? I want to reduce my loads. That's how I reduce my energy. That's how I go to zero. So then the question becomes, at what point down that line, when I go to an R18, an R20, an R30, an R40, at what point does it stop paying? And I can go to an R500 and it's not going to make a difference. That's what energy modeling gives us. That's what we understand. So now when we're working on these project teams, we can come in there and do targeted R values for all of the fabric of the building and all the fenestration. And then once we identify our loads, then we can look to decouple those systems, because when you talk about low flow equipment and technology that you use in high performance buildings, it's not sticking that big box on the roof that does everything and turning it on and off all day and telling ourselves it's the most sustainable box in the world. I want to get rid of that box, right? I want to decouple. So we look for ventilation strategies that are separated from heating and cooling strategies. And things like VRF and air source heat pumps become affordable because you're in such a low load environment that they become, they're not as expensive as they would be in a code-based environment. So now I've decoupled my ventilation, I put on some energy recovery, and I'm getting that almost for free because of the variable frequency drives, and I can run that fan all day long and increase my ventilation. I've excluded all my exfiltration on the building because I have an air barrier that actually works at a certain level. And then I look for my heating and cooling. And most buildings in the United States, in the northeast part of the United States, most buildings don't require heat. You're going to put a heater in, a heating system in, because you have to by code. But in a passive house, for example, in the northeast part of the United States, that is not being used very often at all. So it becomes cooling, right? Cooling becomes our challenge, and how do we solve for that? But by then, I've already gone from this concept of 100, 150 energy use intensity all the way down to a 14, which is a passive house energy use intensity, kBTU per square foot per year. And even if I miss that by 20%, I'm still hands in the air winning. And then when I want to look to my renewable strategy, that renewable strategy is therefore that much smaller because my loads are that much smaller. So now it can actually fit on my roof. So when we come at the problem, we want to talk to our clients about using envelope first strategies, vet them so that they meet their aesthetic goals and their square foot on the inside of the building goals, and whether or not it's existing or new, and then work candidly with the entire team about respecting the natural order of sustainability and the processes of how we get to zero energy. You're never going to fix the carbon challenges we have today with digital science, as great as it is, and you're never going to fix it by adjusting active systems. You have to touch the envelope.
So Craig, you've mentioned Passive House a few times. I don't think, I'm thinking back on 80 plus episodes at this point, I don't think there's been a lot of Passive House an introduction or a deep dive on what that is. Can you just explain kind of what that is real quick before we kind of move on?
Yes, I can. Passive House, in its simplest form, is a performance-based standard. It's really what it is. So, if you look at the history of sustainability, we start with, aspirations back in the 60s, early 70s, and then we went to prescriptive criteria, 80s, 90s, and then it went into performance-based sustainability programs like Well Building and Living Building Challenge, and even Passive House started coming out at that time. And now it's going to accountability. So when we talk about Passive House, and the reason why we use that as an example is because it is the most rigorous performance-based standard for efficiency-first solutions for buildings. It represents the spectrum of what you can do. I would offer, respectfully, code is the other end of that spectrum. Code is the worst building we're legally allowed to build. Passive House is the most efficient building you can build. So when we look at the new emerging standards that are out there for performance-based criteria like Passive House and like Reset Air for air quality, we use those because it ties back to our common thread of using metrics to set goals, to maintain goals during our planning processes, and then to measure those goals to make sure we met them once we're in operations.
And you mentioned in your description building science earlier, but Passive House, it's not only envelope, but they view ventilation differently as well. Can you talk a little bit more about that?
Sure. So there's a concept called hygienic ventilation. And hygienic ventilation, essentially what that means is never breathing the same air twice. And we're not quite there yet, although what's important for people to understand about Passive House is it sets the stage for that. It enables the environment for, that type of ventilation where essentially, you limit exfiltration and infiltration. You start to control your envelope. You keep the outdoor air out and the indoor air in, and you only let in air that you want in and only under prescribed circumstances and conditions. So it's kind of hand in glove with Passive House, and there's an equivalent standard to Passive House on the indoor air quality side, and that's Reset Air. And I don't know if that's something that, folks affiliated with Nexus Labs have been talking much about, but we see that coming to very aggressively. It's the same type of performance standard. Both Passive House and Reset Air set the expectations of performance, but they don't require a certain set of strategies to deliver. So it leaves the project teams up to figure out how to deliver those performance results without having to impose on them in terms of what they have to do step by step, checkbox by checkbox in getting to that.
It's worth mentioning as well, when you think about simulation, and that really is our superpower, is simulation and building energy modeling. When Beth is talking about Passive House for hygienic ventilation and Reset Air to basically help measure that, the energy modeling that we do can all simulate exactly that. We can simulate all forms of energy by zone, by use, by whole building. We can simulate temperature, humidity, and CO2, again, by zone, by whole building, by floor. And we can then understand before we ever spend a nickel on our construction project, whether it's new or existing retrofit, whether or not we're magnitudely going to reach our goals. Now, simulation is a tool at the end of the day. We still have to build the project right. We have to commission the project right. We've got to put the systems in and make sure that they're set up in the right way. But without the modeling, we're really poking and hoping and then trying to fix everything post-construction. Modeling gives us the chance to really start on the right foot so that we can at least magnitudely get there and then measure it once we get there. So again, the difference here, James, and you and I talked about this earlier, the difference is modeling historically has been used for transactional purposes, right? And the MEP creates a model, they give out a paper report, and then they size their equipment. You never see the model again. We feel that repurposing that technology, because the technology is sophisticated enough today to do it, reusing that to then do predictive analysis on the envelope, on energy, on IAQ, and then continuing to inform it all the way through construction processes with submittals and change orders and value engineering or change of systems, all the way through field testing, QA, QC, reinform that model all the way. And by the time you get to the end of your retrofit, you've got a very highly calibrated model that then you can use on operations. That's where the market's going. That's what we do on pretty much all of our projects.
All right, that's a great segue to data science. So let's go deeper into that side of the equation.
So when we talk about data science, what we think about in terms of bringing together design, construction, and operations is how do we take simulation, provide context to data, but more importantly, how do you set up the data to receive it properly? So the interesting thing about where we're at in the industry today in terms of data is that it's a little bit like a cobblestone street. It's uneven, it's disconnected. Sometimes it's, small pieces, large pieces, and there's not one version, one view of how to bring it all together in a way that gives owners, which is essentially what we want, is the eventual ownership, control, and transparency over data to owners. And when you set out and you try to figure out how to do that, it really starts with some basic and simple architecture that I know Craig wants to go a little bit deeper into.
So yes, I do. Only because I'm the one that's usually trying to get the data from those systems, and I'm learning the easiest ways. And James, your blogs are going a long way to talking about that, and I appreciate that very much. But when we talk about, how does Auros Group, why do we care about data science, and how do we get to data science? We want to be involved in the conversations when the data science folks are setting out their meters and sensors and their operational technology deployment. Why? We want to make sure we connect it to our goals and targets, right? Going all the way back to the beginning when we established an OPR and we talked about all those metrics before we did any intervention into the buildings. We want to make sure that our meters and sensors are set up properly so we have the right feedback loops. And I can't tell you how many times we get out there and one of two things happen. Either we're not measuring a goal that we've established that it's easily measurable, or we're over measuring and we're spending a lot of money in our buildings that we don't necessarily have to spend because our engineers got very excited when we talked about meters, and now I've got a meter on every outlet in my entire building. We don't necessarily need that from our perspective, right? If there's a compelling reason on why the facility management team or the owner would like to have that, then great. But from our perspective, it is as simple as creating a use case to the OPR to make sure that we have a feedback loop on that goal and that target. And once we have that, then the question becomes, do I have the data from that? Do I have the time series data? Because if I have the time series data, now I can give that data context. And when I say that, historically, what have we done in data science, right? To get context, we use our historics on the building. I'm better than I was last year, or the average of the last 5 years. Again, that doesn't give us a lot of context because it doesn't answer the question. That building, when it was performing under its baseline, was it performing as it was designed? Or was it underperforming or overperforming? We don't know the answer to that question. So historics doesn't necessarily answer the question for us. That's number one, the context. And number two, we're going to see a lot of people using context like national median and saying, well, you're better than your peer group. Okay, great. That's interesting for about 30 seconds. And then I'm done looking at that stat. The only context that really matters, and it's almost a perfect context, is merging simulation with data science, trended data. Now I can answer the question, is the building performing as it's supposed to perform, number one. And number two, we can also work with those layers of advanced data analytics when they want to come into the building and create these really, really cool analytics and put them in a building. Well, I can tell you that analytic is going to work different in a passive house building and a really bad code-based building, right? You're going to have to put it in place and you're going to have to refine it and play with it until you get it to do what you want to do. That causes frustration from the client. It causes thermal comfort complaints. It causes building occupants to distrust, right, what's going on in the building. And what we're doing is we're working with our teams and our digital twins that we have collaborated with, and we're using the building energy model to test out those analytics before they ever go in the building. We could test out the BAS sequence of operations and set points. We could test out all of the operational characteristics on a building before we ever deploy it. We're not poking and hoping. We're putting in place what we believe will be close. It gets us very, very close. And then there's still that refinement. You always got to refine the buildings.
Hey guys, just another quick note from our sponsor, Nexus Labs, and then we'll get back to the show. This episode is brought to you by Nexus Foundations, our introductory course on the smart buildings industry. If you're new to the industry, this course is for you. If you're an industry vet but want to understand how technology is changing things, this course is also for you. The alumni are raving about the content, which they say pulls it all together, and they also loved getting to meet the other students on the weekly Zoom calls and in the private chat room. You can find out more about the course at courses.nexuslabs.online. All right, back to the interview. So you mentioned benchmarking. Traditional process for benchmarking was to get 12 months of utility bills, compare them against national median, like you said, or the rest of the buildings in the portfolio. And what you're saying is, why aren't we comparing it against what the building is supposed to be doing if it was performing correctly? Makes total sense.
We can know that immediately. We can know that in the first year warranty period. We can know that before building occupants are fully deployed. I mean, those are knowable answers, and the technology exists today to answer those questions.
And flip that question over to an existing building or a portfolio of buildings, right? And you want to know, what's the building capable of achieving? You know, there's an aspirational goal of, well, I want to get to zero energy. Well, without the context of, is the building capable of that, and how far can the building go based on, you know, constraints, and then what's that going to cost? You know, we kind of flip the idea of national median to something better, an incremental move down. What we say is, no, simulate and figure out what the building's capable of, and then start trading off from there based on either what you can afford or what's important to you, right? So we just kind of flip the prism to look at it a little bit differently and use simulation in order to do that.
And you mentioned analytics as well, right? So the ability to have a model on, for this given hour of the day, on today's Wednesday when we're recording this, Wednesday at noon, this building is supposed to be doing this right now, right? And then now we can compare it to what it's actually doing. It's doing this. And that's a great basis for analytical results to come from.
Absolutely. I mean, most of that work is done, and I've seen your last blog where you're talking about psychrometric charts, you know, and that's the merging of temperature and humidity to determine thermal comfort in a building. We're doing the analysis in psychrometric charts for simulation before we ever operationalize the building. I mean, to me, that's answering the question that you want to answer, right? The fee for entry in this discussion is energy and air quality. It really is. Because if you do an envelope first approach to your buildings and you're looking for an efficiency based solution, you're going to get at energy and you're going to get at temperature and humidity and CO2 simultaneously with the same solutions. So that's the fee to entry, right? And then once you're there, then you can start looking at other things that we established in our OPR. We don't ignore light and sound and water quality and water quantity and materials, toxic and embodied. I mean, we cover the full spectrum of building performance. And today we're focusing on operational carbon, and we're focusing on measurement verification and supporting that from building science and data science. But you can get at every aspect of building sustainability when you solve the minimum viable product. And the minimum viable product is energy and air quality, always. Plus it solves the macro trends in the industry, climate change and COVID. I think I'm grasping it. Let me try to summarize the equation here. Building science plus data science. So building science could come in at a retrofit situation or a new building. It's essentially basically saying, I'm going to create a model and I'm going to minimize I'm going to try to meet whatever outcome the building owner has with this model before we turn any wrenches, do anything like that. Data science comes in when the building's operational, or you're in the commissioning phase, like you said, something like that, before the building's operational, when you're actually monitoring and collecting data from the building. Merging the two has a bunch of benefits that has never really in the industry have never been captured before. It makes total sense to me. Anything else to add to my rudimentary explanation there? Yeah, a couple things. Number one, if you have an existing building, having the right smart building infrastructure in place gives us the ability to calibrate that model easier, right? So you had mentioned, how do we historically do this? We get 12 months of bills and we're looking at that. Well, that's 12 points of data, right? For every utility. If I can get hourly data on that, then all of a sudden now I can run that calibration at a much, much higher level. So we use the smart building infrastructure to calibrate the model, and then we use the model to calibrate the building. You see how it flips? That's kind of how it works from our perspective, and they work hand in hand. That's why having a conversation about smart building infrastructure deployment planning is so important early in projects and conceptual design, because without the right infrastructure, we're never going to know the answer to the question. Fascinating.
And I think when you pull those together, so who wins, I guess, is maybe the most important question. How and what does the win look like? It's owners, developers, operators, and the win is about risk, right? So reducing risk. How do we reduce risk? We reduce financial risk by, being able to provide evidence of, here are the paths and here are the steps you take and here's how much it's going to cost. And so now you have a better idea of, before you even put a shovel in the ground or you retro commission a building, you now have a better idea of what your risk profile is financially. Performance risk, right? You reduce performance risk because now you have something that predicts and kind of gives you an idea of what you're able to achieve, so you don't overspend. There's a lot of overspending going on in trying to get to some of these goals. And so you don't overspend. And now then there's the operational risk, which really is all about the context. That once you have different context where you see what the building is supposed to be doing versus what it's done in the past or what some other building down the street is doing, now all of a sudden you reduce operating risk because you have something more tangible. You've got context that is more tailored, more customized to what you're trying to do and achieve in your building. So there's that whole risk issue. And then at the end, it's just more affordable. So if you want to tackle the idea of zero carbon, or you're going after, higher fruit in the tree of the ESG goals, right? And you're trying to go higher and you're trying to get more, the most cost-effective way to do that is to bring together the building science and the data science and have kind of one approach as you think through your choices and your options. So.
Cool. All right, let's talk about how to deliver this. The first thing that's coming to my mind is that delta between code, worst building legally that you can legally build, and passive house. And I was just writing a newsletter this morning, and so it's on my mind. And the newsletter was just summarizing, like, what does society have to do to get to net zero, right? Well, essentially, we have to get every new building to zero carbon ready by the time the grid is ready for it. And that has to happen by 2030, which means codes have to happen by 2030 to close that gap between worst building possible and passive house. What do you guys think? Is that going to be possible at all to close that gap between, worst building possible and the buildings we actually need?
Well, I would say if we're depending on code to drive us there, I'd say probably not. As we've talked about, the tools exist and the building science strategies and thought processes and principles exist to get there today. But, where are we on this innovation curve is really the question. How do we hit that inflection point where everybody kind of says, oh, okay, got it. Craig said early on, once you see some of these details, you can't unsee it. So how do we get more people to see what this is? And then that's when we hit that inflection point. But, code's certainly not going to drive us there. There are some cities who are implementing some objectives. Pittsburgh's one. It's got a zero energy ready goal on all of its city buildings. New York's going after it hard. There are a lot of cities in California, but for the most part, code's going to follow, probably not lead. So now we need leaders to kind of step in and take over, and how we identify those or how people self-identify as leaders in this space. That's the question, especially for, people like you, James, who are writing on these subjects. How do you invigorate and compel audiences to at least want to, learn more, at least want to dive in and try. That's where we're at today. Once people jump in, they're not jumping out. So, that bodes very well, I think, for the future and trying to get to where you just suggested we go in 2030. I think it's possible.
Yeah, the newsletter that I was writing this morning will have come out by the time this gets published. But I was basically saying, for 2022, for your career, what problem would you rather work on than this one? It was a challenge, and I will put that in the show notes to anyone that wants to read my challenge. So Craig, you mentioned OPR a few times.
Yeah.
Can you talk about the importance of the OPR to actually making this happen? What is the OPR?
The OPR in simplest terms is a plan. That's really all it is. And when you think about what you had mentioned before, I want to connect a couple dots here. So buildings use 47% of the energy in the United States. They're by far the biggest users of energy. They by far are the biggest contributors to climate change, number one. Number two, by year 2050, 80% of the buildings that will exist in 2050 exist right now. So the problems we face are not going to be fixed with new construction. I think the codes are getting better and they're stretch codes and they're trying, but that's, we're not going to build our way out of this problem, number one. Number two, we're not going to renewable our way out of the problem either because we don't have enough rooftop space in urban environments. We simply can't fit enough PV in those areas to renewable our way out of the problem. We have to honestly address existing buildings, and we have to figure out how to do them. So when you ask me about an OPR in its simplest terms is a plan. We are sitting down with the clients and we're saying, what's the culture of your business and your building occupants, and how do you want this building to operate? And we define that by metrics, and we apply it to a building. We can apply it at scale. And then we bring up a model, especially in existing, because this is where we need to focus our efforts to get at these goals. We can bring up a model and we can match that model against the OPRs. And now all of a sudden we can create a plan, an investment plan, if you will, for owners. So any owners that own a group of buildings can come here and say, okay, building 1 is an underperforming, building 2 is an overperformer. We can see where all of our low hanging fruit at is, and we can start to make investment decisions. There is an ROI on transforming a building from 100 EUI to 14 EUI. There's an ROI on it, and we've done it frequently. A lot of building owners are starting to understand that. So they're making those decisions for business decisions, they're making those decisions for regulatory decision making, and they're making those decisions because they have natural triggers. Let's imagine you're in a building and that building mechanical systems need to be replaced, and you have to invest $4 million or $10 million into invest or to replace that system. Are you going to want to look at efficiency first strategies at that point in time? I mean, it's a natural trigger. If I have my plan, my OPR and my model up, then I know what the low efficiency solution of that building is. I know what its technical capability is. Then I can make those business decisions like Beth said. Rather than working from code down, which is insane, let's work from what the building can do, what its technical performance ability is at the highest levels, and work our way up. And the only thing that stops us is financial decision making. That's it. So to us, when we look at that, the OPR is nothing more than a sophisticated plan, just like the building energy model is, and it gives us the pathway to make better decisions on how we want to address these buildings.
It sounds like that this doesn't need to cost more. And Craig, you mentioned that a few times. The cost for getting to these targets doesn't necessarily need to be more than we were planning on spending to accomplish business goals anyway.
Right. So when you think about the OPR and the benefits of the OPR, again, who wins with the OPR? The owner wins because in the OPR is embedded metrics, and the metrics are to reflect what's important to the owner and what they want to measure in operations. What happens generically or organically, what happens is it aligns all project team members to those metrics. The best way to get architects, engineers, construction management firms, commissioning agents, building management companies, operating teams, the best way to align them is to metrics. All of a sudden, it kind of unleashes people because paragraphs of narratives do not align people. Paragraphs of narratives create gaps in accountability. Numbers creates aligned accountability. And so when we talk about the OPR and why it's so important and what does it have, it's all numbers. It's one page, a very long page sometimes, depending on our client. But it's not a book that sits on a shelf with a bunch of narrative in it. In terms of what does that do for costs? Well, I mean, think back to this entire conversation. There's nothing we talked about that's new. There's nothing we talked about that doesn't exist already. It's not about any extra cost. It shouldn't cost any extra. Building a really good building versus building a code-based building shouldn't cost any more. It's all in the order of operations. It's all in how you bring the right people into a project at the right time. So we fundamentally believe that the cost argument is it's legitimate and it exists today because we haven't done some of these things in the past, because owners have invested in things and they've walked away a little bit, frustrated. Like, I don't know if I got what I paid for. I have a plaque on that building over there, but it's not performing. Smart does not necessarily mean high performing. And, that was the subject of one of the ebooks we put together, because we had to kind of unravel this idea that just because you have data doesn't mean you're actually going to be able to get to a really high performing building. There are other things you have to do, other things you have to consider in order to really get to the optimal performance of a building, what's it theoretically capable of achieving. That takes a little bit different look through the prism.
Hey, James, I love this question on cost because it's a loaded question, right? And I'll explain why it's a loaded question for your audience in terms that they can understand. So let's assume we want to get a data analytics platform, a layer on our building, right? Digital twin, doing analytical data. How do they get their data? Right? They come in and the owner wants them. How do they get their data? They got to connect to the individual OTs or distributed sensors. They got to connect to the BAS, whether it's proprietary or open, and they got to pull their data out of that building themselves. It's a labor intensive process to get that system up. And then from an O&M and operations and maintenance perspective, it becomes an expensive system to maintain, because when you have a failure in a point, you're chasing 800 different connectors and, not just one. So it becomes a challenge. So when we look at that and we say, well, wait a second, can we do things better? What if I put a data aggregation appliance in that building, and then I created a central point for the data to come out? I can control security. I can control single pane of glass. I can start, now all of a sudden we can make better decisions. But what happens on projects traditionally, we let our MEPs who don't understand Division 25 as well as maybe they should come in and design a traditional system with a traditional BAS, and then they try to plow OTs into the BAS. That's not cost effective. That doesn't work. Or we're doing things post-construction after the building is already built by coming in and swinging 25 more networks in the building instead of using a converged network, or even if it's just a simple OT converged network. So the point I'm trying to make here is that the question you've asked us about building science and costs relates to the data science the same exact way. If done right, and if done early, you could do it at par. You could actually might even be able to save a little bit of money if you're not spending money on all the proprietary systems that are out there. You can manage your own system in a robust, durable way, flexible way, and do that right. The same concept applies to building science. And I'll give you an example. One of the developers that we work with, a large developer, was doing a large 250-acre development project. And they had one of their key buildings, and they wanted to have this building be aspirational, right? Be a high performance building. So they went to their contractor and said, okay, here's the estimate on that building that you have for us. We want this to be a high performance building. Can you rerun your estimate? The contractor went down, and it's called the Construction Standard Index. That's how they organize estimates, right? Per spec book. He went through the CSI and he applied a 5% factor on every single element of work. And we asked him, said, well, wait a second, if you ask him how much more it's going to cost you, he's going to tell you it's cost more because you just loaded the question. When does masonry cladding know it's in a passive house? When does it care it's in a passive house? It doesn't. The passive house has to do with insulation, thermal barrier, fenestration systems. That's it. That's the only elements I want to talk to you about. But when we don't educate ourselves on how to get to that process, we tend to spend a premium on the learning curve, just like in data science, right? So when we look at this, our argument is simple. Done right, done early, done with the right factors, we can do a passive house project of any size at par, because insulation's always cheaper than systems, always.
Fascinating. Thanks for that. It's a good, I like that passion. I think that's a good place to sort of wrap up. So it's pretty early in the year still. What are you guys looking forward to in 2022?
I would say I'm looking forward to seeing people jump on the bandwagon of some of the leaders. And we talked earlier about, what New York is doing and what California is doing. And I think now 2022 is going to be where the fast followers step in. There are a lot of municipalities and building owners, large hospital systems, universities that, didn't necessarily want to be on the fuzzy front end of innovation and of disruption, but they absolutely want to be fast followers. I think 2022 is going to be the year for fast followers. And I'm super excited to watch and see, kind of who decides to step up and what they do when they do step.
Awesome. What about you, Craig?
So for me, I think we just spent the last 2 years and probably most of this year trying to figure out how do we deal with climate change and COVID within our buildings. And I think that we're starting to see a lot of really interesting solutions emerge from that. I think what I'm looking forward to seeing is owners wake up and understand that this is coming. We see so many owners at different events that put their head in the sand and figure out that, New York City passed legislation on carbon reduction. They didn't tell you how, they didn't care. They said by 2030, you got to reduce by 40% and 2050 by 80%. That's massive. And you don't get there without touching the envelope. And the building owners that we talk to are simply, some of them are saying, well, that'll never happen. They're never going to do that. And then you have some of them are starting to figure out how to get there. And what we look and see is that is not isolated to New York City. We're seeing all cities and states starting to take on that same challenge. and they're adopting it. If you look at the cities that have adopted the Paris Climate Action Plan, you're seeing those cities that are going to step forward and say, listen, we're going to require buildings to decarbonate and deal with this problem. So for us, we're excited because we're speaking to a lot of building owners about being proactive in that discussion. And the way you be proactive is you take advantage of your triggers right now and start to transform your buildings. Otherwise, you're going to have to do this all at once. And that's where it's probably going to cost a premium to get there, but it's not going to change the decision makers from getting there. They're going to make us get there.
Fascinating. Thanks for that update. I have hope talking to you guys. So I appreciate you coming on the show. Thank you.
It was very exciting. We really appreciate the opportunity.
Thank you. Looking forward to reading and seeing everything you do in 2022 also, James.
Me too. Who knows what's going to be. All right, friends. Thanks for listening to this episode of the Nexus Podcast. For more episodes like this and to get the weekly Nexus newsletter, which, by the way, readers have said is the best way to stay up to date on the future of the smart buildings industry, please subscribe at nexuslabs.online. You can find the show notes for this conversation there as well. Have a great day.